Okay, hello everyone. Good afternoon. And we have having this very small class today. But just a few words regarding the topic proposal. I have not yet finished the grading of all the revisions. I think there are probably half of the students submitted revisions. It takes me a lot of time to do the revision, to do the grading and look into the content. As I mentioned, the cutoff date has passed, so whatever feedback I gave you, try to incorporate into your future paper or your project. I think some students still have an issue with how to narrow down the research topic. And I really don't want to see textbook-based discussions. If it is well understood in the literature, try to avoid those lengthy discussions. You don't have to mention the importance of encryption, cryptography, wireless security, the use of modern security protocols. Those are not research issues. What I mean by research issue is that it's an unsolved problem, and there are still some new approaches being proposed. It's very important, and the solution has not reached yet. So which means that there will be some space for future improvements. And that's what I mean by a researchable problem. Textbook contents are generally not researchable topics because people have agreement on those issues. So for example, intrusion detection system is an ongoing research topic. IoT security is. There are some other issues with operating systems, database systems, multi-factor authentication techniques. Those are all ongoing research topics, but try not to show the content that is only based on the past, the content that can be discovered from a textbook, which means that for the body of literature, for example, the importance of IDS, different categories of IDS, anomaly-based, signature-based, hybrid system, don't write anything on those issues, okay? Those are not research issues. But if you write the same issue 30, 40 years ago, it's a big contribution. I still remember when I was in graduate school, I read a paper published in 1984. And the author was Dorothy Denning. And some people call her the queen of cybersecurity. And her contribution was to propose a way to categorize different intrusion detection systems. And now you can see the content from any textbook. We all know there are different types of IDS. Here is signature-based, and you define a signature, a very large database that includes all those signatures, and then you can detect the attacks very fast. Another category is called anomaly detection, which means that anything deviates from the normal behavior will be called the intrusions. And she put different categories there, and she published the paper in the top journal in the field. That is IEEE class actions in software engineering. That's a huge contribution at that time. 40 years later, you cannot write on the same topic because it is well understood by all those research groups, right? And people follow different traces to develop their own ideas. I want you to go into the frontier of research, not a research topic proposed 10, 20 years ago, but the current research, right? Published in the past 4 or 5 years. And what are the newest approaches? How do they adapt to the newest attack vectors? And those are the contents I was looking for, okay? So try to avoid very broad discussions and also avoid the contents that can be found in a textbook, all right? Whatever topic you have, I don't recommend future revisions. After this is the last round. I think I have given you enough time to revise the topic. Some students only go through 2 iterations. Some students go through 5, 6 iterations. I cannot afford you change your topic as in the last minute. So whatever topic you have, move on with carry on the topic and move it on. Right? just remember my comments. If you don't have a grade of 5, it means the proposal did not meet my expectation. Right? But normally a grade of 4 is very close. So some people submitted different revisions, they still have the same grade because it is still there could be some distance from what I'm looking for. Okay. I really hope that you can delve into the research, do some concrete research, do your homework, find the publications, read the papers, and then propose a meaningful topic, right? And I want to make this a technical class. So if you want to review the policy, the regulations, the compliance issues, try to dig deep into it and find some technical elements inside that topic. Don't talk about, HIPAA is a big thing for NSU because we have a very big medical school. If you talk about HIPAA compliance regarding patient records, regarding some private information for different medical records, yes, you can do that, but try to find some technical issues behind it. For example, what encryption technique you want to use, how strong the encryption should be. Don't stay on the surface of the topic, right? If you can find similar contents from a news article, it means that you did not go deep enough. Right? All right. So I will try to finish my review as soon as possible. It postponed my grading on the previous assignment as well, because here we have close to 60 students. Everybody submitted on average 2-3 iterations. That's a lot of work. Sometimes it's beyond my area of expertise, so I have to do additional research. I'm not an expert with everything, only in selected areas. So I have to do the research, read the papers, same thing as you did. Right? If you did not do the work and I did, then you really fall short of my expectation. If I can do the work in probably 1 hour, half an hour, and you didn't spend the time on it, then that's not acceptable. All right. All right, this time we will discuss some fun stuff, the buffer overflow attacks. I hope this topic is not new to you because the textbook had some discussions. But I really want to bring this to some hands-on experience that you can experiment on. So this is part of the 4th assignment. You don't have to do it. If you choose to do it, I want to give you some guidelines, right? This is one option in the 4th assignment. All right. This will go much more detail into the technical aspects of buffer overflow. App open. All right. So you all heard about buffer overflow attack, and the textbook discusses it, but how to implement this? We want to set up some very simple experimental environment so that everybody get a feel on what buffer overflow is. Okay. The purpose, I want to make this as simple as possible. They're very complicated buffer overflow attacks. Sometimes it's highly dependent on the architecture of the computer, the instruction set, whether it's ARM-based, RISC instruction set. So you can drill all the way down to the design of computer chips, all right? And every chip supports a specific instruction set. Every general purpose of CPU. If you have been in a computer architecture class, you know what I'm talking about. All right, that's an overlapping area between computer software and computer hardware. Okay. All right. All right, so we will discuss a little bit on the foundation. It's very simple to understand it, and then we will show a case study and the experimental setup. All right. Again, this could be optional for some students. If you don't feel very comfortable with the experiment, or you have never ever write a C program before, then maybe this is not the option for you. Okay. All right. So what is a buffer overflow? You can easily find the definition from by using Google search or from the Wikipedia page. This actually come from the Wikipedia page of buffer overflow. Right? It's an anomaly where a program, while writing data to a buffer, and buffer is a very important space inside the memory, and different operating systems support different data structures. This is how we store the data. We call it a buffer. Right? It's just basically is a storage space. Each time when you run a program, it has to be put in some kind of storage in the main memory of the computer. Whether you use a cell phone or whether you use a Mac computer, desktop, laptop, they all have to be fed into the main memory. And this is called the read-only memory, right? To be executed. But there are some requirements when we use the buffer. Sometimes when we allocate space for a specific parameter, if the program does not perform the boundary check and the operating system does not have a security system to guard the allocated space for a specific parameter, then it has the potential to override adjacent memory locations. Okay. It can be triggered by the inputs that are designed to execute code or alter the way the program operates. So basically, it changes the flow of the program that was designed to be. Right? Every program was written by human being. Although we have the ChatGPT stuff, they still learn from people's code, right? So the program has to follow specific grammar. Different programming languages have different grammar that you have to follow. How to define the beginning of a program, where is the end, how to define parameters, how to control different parts of the operation. The program is a man-made artifact that perform some jobs that people intended to do in the computing or the digital world. So when a buffer overflow happens, it will cause unexpected outcomes, which includes erratic program behavior. The behavior cannot be predicted, or the memory access errors. It could be the other parameters when you use them, they can no longer access the memory, or results. So the outcome could be different from what we have expected when we write a program. It can also cause a crash of the program. Wow. Those are not bad consequences, right? Generally speaking, even if you crash a program, you cannot do anything, but you go back to the starting point. This is not a very bad consequence. A very malicious consequence could be the breach of computer security in terms of integrity, in terms of transfer of control, or in terms of confidentiality, to steal the files in the target system. It can transfer the control by changing the privilege of a normal user into a super user. That is the administrator of the computer. So they can take full control on the system, on target system. And we have seen so many incidents in the real world, okay? And if you can recall, one of the major attacks that happens, we call it advanced persistent threat, APT, happened in the real world, was about 10 years ago. A nuclear facility in Iran was taken over by malicious program. And the outcome was to burn the nuclear centrifuge of that facility. It technically postponed Iran's nuclear program for about a decade. Right? It burned out the machines by conducting a buffer overflow attack. There are a lot of technical issues, how to make it successful. And probably you heard about it. I was during my way driving here, I was listening to the radio. And we have some new conflicts between Israeli government and the Iranian government. And because of the missile strikes, it seems that the war might be escalating. And there are a lot of unpredictable factors because of the inauguration of the new president. We may change our foreign policy. So, but the basic problem from technical standpoint is that the buffer overflow attack really works. For that stocks attack 10 years ago, it takes advantage of a buffer overflow attack on one of the industrial control boards, ICBs, produced by a company in Germany, which is the Siemens. They modify the program. Of course, it takes a lot of combination of techniques, including might be social engineering, how to entice somebody to plug, this is just a suspicion, right? There is no concrete evidence. We suspect that, there is an unused USB being left over around some of the technical people for that nuclear facility. Somebody pick it up and then plug into one of the computers for the internal network. And that program has started to work. But it cannot attack the target directly because the computer is not directly tied to the PCB board. So it may take days or even months for that dormant program to gradually penetrate from the external network into the internal. And at some point, there are some trigger events that trigger the execution of that attack. If the attack is started very early, it cannot be successful because all those nuclear facilities, they have a lot of security people there, and they know how the buffer overflow attack works. So there are some advanced detection techniques that they can detect the attacks very early. But somehow it was able to bypass all those security checkpoints and be able to execute. Right. And the basic idea is that once the buffer overflow attack happens, it takes over the admin privilege of the target machine, and it causes the thermostat of an industrial control board to malfunction, which will trigger the event to make the control board. The control board basically controls the temperature within the centrifuge. It has to be regulated in order to conduct some nuclear level experiments or produce nuclear weapons. So if that temperature regulator does not work well, it causes the nuclear facility to overheat. So basically, it burns out, all those, centrifuge and all those key equipment. So that's it could be a hypothetical story, but the outcome is that, well, their nuclear program has failed, right? Because of that attack. Right? But I think the Iranian government was able to pick up that nuclear program because they have a lot of super talented people as well. Iranian people are very smart. There are some researchers in the U.S. Working super good universities. Like 2 years ago, one female Iranian scientist received the Nobel laureate in mathematics. We call it the Fields Prize, right? If you heard about it. Some of you maybe in the math major, you know what Fields Prize means. It's the top tier Nobel laureate in the mathematical field. Only given for somebody I think is younger than 35 years old. You have to get that award when you are very young. Now, when you become very old, you're not qualified. But anyways, buffer overflow attack is extremely malicious. It could be super powerful. Although in today's computing world, the operating system has been stronger than before. Most operating system does not allow you, even if you write a bad program, the OS says, no, we cannot execute that program. You remember when you answer the assignment questions, there are two types of defensive techniques regarding buffer overflow attacks. One is called, anybody answer me? what is the first category of defense against buffer overflow attacks? First one is
Secure software development.
yeah, it's called compile time defense. So when you have a compiler, yeah, of course, yeah, the bottom reason is people make mistakes, right? But from a defensive point of view, how to defend? We have programmers that could write bad programs. There is a very little security check, but how as a defender to prevent this? So there are two defensive techniques. One is the compile time defense. The other one is
sanitization.
the sanitization. All right, yeah, that is called execution time defense. When the program has been converted into machine code, you can still defend against it. So all those defense mechanisms either can be done at the compiler level, especially for low-level programming, you have to use a compiler. Right? Java is a different animal. Java still uses a compiler, but it's different. We translate the code not into the machine code, but we call it byte code. Right? It's not low-level machine code. But if you write a C program or assembly code, you have to use a compiler to compile the program before you can execute it. So the first level of defense is the compilation time defense. When you write a program, you will check the boundary of those parameters to see whether they are being guarded or not. The other one is mainly done by the operating system. When you execute the code based on certain architecture, in all those desktop or laptop computers, we use x86. That's basically the architecture proposed by Intel. And later we have some other architectures like RISC, like ARM. Every cell phone today we use, especially for Android devices, they are essentially based on the ARM architecture, which is a company in British. It's a Great Britain company, right? And whenever the vendor sell you a cell phone, they have to pay for the real royalty by using that architecture, right? So two types of defenses. One is called compilation time defense. The other one is execution time defense. Okay. It is doable, but it's still very challenging. And because of those defensive techniques, the occurrence of buffer overflow attacks are relatively rare compared to 5-10 years ago. But still, you can see a lot of cases. Okay? The bottom line is that any code that is executable has the potential to be compromised. Right? All right, so we have a little bit history behind programming languages. And there's a big family for the C, C++, and their derivatives. The original operating system was all written in C, okay, including the early versions of Windows operating system, the Linux, the Unix, all those operating systems are written by C. And of course, C++. And in the modern days, we still use C derivatives. For example, if you write a mobile app on your iPhone, you can use a language called Objective-C, which allows you to embed the original version of the C code into the program and execute it. Right? So every cell phone is susceptible to buffer overflow attacks as well. Okay. You may wonder why they are so powerful. That can cause so much damage because it's mainly a balance between convenience and efficiency. The reason in the modern days, the reason we choose C++, C++, and derivatives is because of their efficiency. They are highly maneuverable. Instead of like all the scripting language, like Java, like Python, or like JavaScript, VB script, we execute them in a safe environment called a virtual environment, called JRE. Java is called Java runtime environment. And basically, it's a fancy story. Right? You write one program, it can be executed in different operating systems. But in C, in every operating system, you have to write different versions of the same program because they support different APIs and different libraries. And C and C++ are powerful in the sense that they can be very fast because they are very close to the machine code. right? There's only one layer of translation. If you use a compiler to compile the program, you get the machine code, right? Which can be directly executed. The other thing is that C++ originally was designed to be a generic programming language, which allows you to program literally any applications, including the operating system itself. At the operating system level or the database level, it handles all the low-level operations, such as the manipulation of memory space, the file storage, the input-output systems, the interrupt. When you design all those functions, you cannot use a high-level programming language because those functions will be called numerous times, maybe millions of times. So if you use a high-level programming language to implement the same functionality, it will be super slow, which is not acceptable. In the future, some of you might be working on some hardware level based control, such as designing a device driver for some equipment, plug and play devices. You have to use C and C++ and a combination of assembly code. Right? There is no second choice. It is super powerful. It gives you the functionality to directly manipulate the memory space at a bit or byte level. You can directly manipulate. You know exactly where the data is being stored and where it's executed. And you can change the pointer to point to any of the memory spaces. But most of the programming languages we use today, especially the scripting languages, Python, Java, you cannot manipulate memory space. So it is very convenient, but the power of C and C++ also bring in the chances that it is easy to create vulnerable programs. If you do not handle those memory manipulation carefully, it becomes more dangerous. So this is really a balance between convenience and efficiency, which language you choose from. Okay. In some cases, you don't have other choices. All right. So in C and C++, it provides no internal protection against accessing or overwriting data in any part of the memory and do not automatically check that data is written to array or any of the data structures. Okay. But if you design a compiler, you always perform good boundary checking. Technically, you can prevent most of the buffer overflow attacks, although you cannot say you can detect 100% of them, because for modern programs, it's super complicated. If you have a program that with 100,000 lines of code, you cannot easily detect all those potential buffer overflow attacks, right? Yeah, there's a lot of code, right? It cannot be easily parsed by manual checking. Okay. All right. So what is a buffer? A buffer is a continuous block of computer memory that hosts multiple instances of the same type of data, especially the parameters defined within the program. Buffer overflow attack is a kind of attack that is executed by the means of software, but it results in a violation of memory safety. I would say to successfully launch the attack, you will need knowledge not only in software design, but also in the hardware in terms of the architecture of the target machine. Okay, because every buffer overflow attack has to be tied to specific operating systems, as well as the architecture of the target machine. Okay. And there could be other variants of buffer overflow attack, including the stack overflow, the heap overflow, integer overflow. Those are different data structures, but buffer overflow attack is the most widely used attack. All right. Any questions so far? Comments? All right. Okay, let's show a case study on how to conduct, write a buffer overflow. It's hard to claim this as an attack because there is no real damage here. Right? This is just a showcase how to make it work. All right, Suppose we have a C program, all right? This is how we define the parameters in the C program. This char means it's a character. Normally it means it's a character string. It could be a name of a person. It could be some kind of statement, whatever. And A, you have a bracket here, which has a parameter 8. It basically tells you that this character string has 8 characters maximum, right? That's the assumption, right? This is the definition, right? And here you have equal sign, and you have the quoting marks. So which basically means it's an initialization. We initialize this character string as something that contains nothing. So basically it says I have nothing so far. It's just an initialization. So when the program runs, it will allocate some space inside the buffer and tells it, I'm going to initialize it to a null string. This null means that I'm going to initialize all the values to 0. Okay? Yeah, this is all zeros because the same space might be used before by other programs. There might be some residual values being stored there. So once we initialize all those values, it wipes out all the previous content, whether it has something or not. We don't care. We just wipe them out. And the second parameter, which is called the B, of course, when you write a program, you want to put some meaningful things. That's the convention. When you write a program, you try to make all the variables really meaningful. Only by looking at the name, you can guess what it really means. Right? This is just a simplified representation. So this is called unsigned short. This is called a short integer. There are different types of integer. For example, in a 16-bit system, the short means that an integer will take over 16 digits, binary digits. In a long integer, it will consume 32 digits, right? But this will be highly dependent on the operating system we use. In the modern days, even for a short integer, could be 64 bits, right? And I believe most of the Windows box today are 64-bit systems, which means that the basic unit you want to allocate will be no shorter than 64 bits, which is 8 bytes. Right? So that's what I mean, that every attack is highly dependent on the operating system we use, right? Because the data structure will be different. So this is called unsigned, meaning that we will not allocate a specific digit to represent the sign, whether it's a positive number or negative number. This is called unsigned integer, right? So when we store all those values inside the buffer, here is what it looks like. Right? Remember the initialization step? This is a null string, meaning that we contain nothing, but it's not actually nothing. The null is a special character that can be defined. So during the initialization, we're going to wipe out any of the previous values inside the main memory. So we initialize everything as zeros. And 0 is a special character. It is a null character. It does not mean actually nothing. We have something here. Okay. So this is parameter A. Normally, when you have two consecutive definitions, the two parameters will be side by side in storage. That's the normal practice. So this is parameter B, 1979. Right. This is a decimal number. So in terms of, can you do the conversion here? Why this is 07BB? Can you do the conversion here? And what is 07 means? 07 means 0, 0, 0, 0, 0, 1, 0, 1. No, 0. This is 4 plus 3, right? So it will be 1. Yeah, 4 plus 3. It will be 1, 0, 1, 1. Right? Make sense? So this is BB. B is basically 11. 11 is 1. It will be 8 plus 3. Right? So it's actually 8 plus 2 plus 1. So it will be 1, 0, 1, 1. All right? So if you want to do a simple conversion, why we have those values? Let's see how it works, okay? Yeah, I'm really trying to break this down to the bit level. And this is the technical level I want you to possess, right? So how to convert decimal number into a hexadecimal number? So let's do a conversion here. Oh, yeah. So we have 17, in Windows operating system, there's a simple calculator here. Let's try to use it. The calculator has multiple settings. One setting is called a programmer mode. Okay. How it works. And actually, you can choose from here. There are different options. Either you can choose standard. I believe in normal daily life, I will use this interface. But here you have another option. You can also choose the scientific calculator or a programmer mode. Okay. So remember the number here. The number was 1979. So you put 1979. And you can see that right now it's a decimal number. So DEC means a decimal number. So what's the equivalency here? And you can easily find the equivalence. This is binary number. Remember, it's. And now we have the 7BB here as a hexadecimal representation, right? So this is hexadecimal representation here, right? This is 07BB. It's here. That's exactly the value we have stored here, right? That's the hexadecimal. That's a unique translation. Now, as I mentioned, the binary representation for 07 will be 0111. So this 7 is 4 plus 2 plus 1, right? So that's 0111. You follow me? You good? Everybody? So what will be? B is 11. 11 will be 8 plus what? What is 11?
11, binary?
Yeah.
Would that be
8 plus
8 plus zero, so 1010.
1010. You get the email.
Sorry, 1011.
Okay, good, very good. Thank you. Yeah, so this 1011, that's character B. Right? And this binary representation, it will be the first one represents 8. Second is 0. The third one is 1. That represents 2. Last one is here. So this is 8 plus 2 plus 1. Right? So that's the letter B. Right? It has decimal representation. Make sense? And same thing here for the last one. Right? So you can see, from this simple computer calculator, you can easily convert all those numbers. Okay. The decimal number representation is 1979, which equivalent to the hexadecimal representation of, it omitted 10 before it, right? So this is basically 07BB. Make sense? Everybody? All right. Simple math. All right. So we're good so far, right? That's the actual storage being stored in the main memory. And now we perform a special function. This is called string copy. The string copy has 2 parameters in the brackets, in the parentheses. The first parameter is the target space. So here, basically, it refers to parameter A that has already been defined. Yeah, parameter A originally was empty, nothing being stored here, but now we want to write something into it. Remember, the default space we allocated for parameter A is 8 characters. So, and right now we want to write a string into it. And this string has how many characters?
9.
It has 9. Count it. Excessive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters. It will cause a buffer overflow. Yeah, this is not attack yet, but this just showcase how it works. Can you predict the value after we execute this command? Can you predict it? After we execute the string calling, what's going to be the content within the main memory? Assuming it's being written sequentially. So we will still follow that order, right? Excessive, EX, C, SSI, VE. We still follow that order. So we're gonna write into the main memory. To follow that sequence, you have E, X, E, EX, C, E, S, S, I, V, E. Right? So the basic idea is that we are going to wipe out content here and put the letter E here. This E refers to the last E. Here we have multiple E's. So it basically is the last E being written here, right? Make sense? You follow my discussion? Very simple technique, very a mechanical process. Yeah. But the thing is that in order to make it successful, you have to disable several security measures in the target machine. Otherwise, it will not be executed. More than that, right? This character string has a special feature. Every string has what we call a terminator, which indicates the end of character string. So that when we store the data into the memory, you have a separator. It's consecutive space in the main memory. So you'll probably have more spaces after this or before that, before the first one. So how do we know where is the beginning and where is the end of a character string? So the way we do this in C programming language, by default, when you store something into a character string, it will automatically attach a special character called the null character at the end of the character string. What is a null character? This basically means, yeah, that's the null character. Each one of this is a null character, which means that after that operation, we will write E here. Additionally, this is not enough, right? We have some unseen line character string terminators here, which will also be used to be stored here. Okay. So here you have E being written here. Additionally, we will wipe out this BP here and write a null character. And now can you predict the value? Before I tell you, you read the program, you test it out, you can actually predict the value here if you can disable all the boundary checks. So what's going to be the value here? This letter E. This is null character. We know null character is all zeros. What about letter E? And remember, the default encoding scheme is called the ASCII format, which has can be traced all the way back to the 70s, 1970s, 1980s. And basically it was designed by IBM. IBM was a super big computer. It's the Apple and Google back 40 years ago, right? IBM basically dominates the entire industry. Okay. And without IBM, you cannot see a company called Microsoft. Okay. So it defines the scheme. So what E can be stored here? You don't literally store the letter E here. You store the hexadecimal value or the binary value here in the memory space. Actually, it's all binary. Okay. We just sometimes use the hexadecimal representation to showcase the binary content because it's more compact. Each hexadecimal representation, each character represents 4 different bits, right? It's more compact. So what will be the hexadecimal values being stored here after we execute this string copy statement. And now, we will pretty much know the letter E will be stored here. So what's the actual value of letter E? Let's see. So here is what we call the ASCII table, right? You can Google the internet, you can find everywhere, right? So you may wonder, where is the null character? Null character is here. It's the very first character inside the table. The table has 128 items, right? Starting from 0 all the way to 127. Why 128 items? Because that's an 8-bit system. In the early stages, people think if we design a computer with only 8-bit, it is pretty sufficient for most of the applicational needs, right? Nobody envisioned, after 40 years, the cell phone has a 64-bit system, right? Even the basic operating system support up to 64 bits. But this is the early stage. We use that table until today. And we still use this mapping table to convert all the known letters. For example, there are some special characters here, right? So these are the characters. Some of the characters are used for the early stages. The typewriter, there's a backspace, there's a carry return, all those commands are being embedded here. In addition, it includes all the English letters, uppercase and lowercase. See, A started with 65, right? Hexadecimal. So this is letter A, B, C, D. It means 26 different letters, all uppercase, and then followed by all the lower cases. These are all the lower cases. Okay. So we are fortunate. The modern computer is based on English language, right? Because the Americans invented computers. We take advantage of it. For other countries, they don't have that benefit, right? But people later proposed some other encoding mechanism similar to this. Okay, but ASCII format is the most widely used, even inside internals of the computers. At the instruction level, we use English, not any other languages. Very fortunate to be able to have that luxury to represent all those characters, all the English letters directly. Right. So you may wonder, remember the previous letter? The excessive letter that has been written. What's the last letter? What's the last one that caused buffer overflow?
The last letter was E.
Then the letter is E. So can you find that letter E from this table? It's a lowercase.
Yeah, the 101.
101. Beautiful. Yeah, this is the decimal value of letter E. And you can convert this into hexadecimal, which is, what's the value here? Hexadecimal?
65.
65. All right. So remember, this 65 is not decimal number. It's a hexadecimal number, right? In that system, we have letter A, B, C, D, E, F, right? So this is 65, and this is 101, right? And this is an octal number, right? So you will have 8 digits, 0 through 8, 0 through 7. Okay. Anyway, you have 65 here. Remember this. So now go back to the question. When you write letter E here, what's going to be the value?
165.
65. Yeah,
65.
table. Yeah, it's 65. So this value will be written. That's the actual hexadecimal value that's going to be written into the memory. So that's 65. So now you can predict the value. So I also did a little bit manual conversion. 1979, that's the binary representation. That's a hexadecimal representation, right? Just the same information you can see from that calculator. Okay, that's the original value. After we overwrite all the contents with excessive content beyond the capacity of a parameter A, here is the value. And you have 65 here, right? Now, what's the equivalency here, right? 65 equals to what, right? So 65 is from the ASCII table, is the lowercase e. And 00 is the null character, which shows the end of the character string. So all the previous values, remember the previous value, 07 BB, and now has been taken over by 6500. And that's a buffer overflow. Okay. Of course, there's no real damage other than overwriting the value of another different parameter. But remember that parameter could be used to control some other things, right? And this is not really the value we anticipated. It changed the flow of the program. It changed the control of the program. But this is not our design. Okay. So it may cause some real damages in the real world. Okay. The minimum one could be the crash of the program. Okay. All right, if you have such a program that used in the production system, it can cause unknown consequences. So yeah, this is basically what I mean. I want to show you a very short case study, and you can see all the values here. Excessive, EX, SS, IV, E is here. And here is the terminator for the character string. Okay. And you may wonder, what about this value here? This is 25856. That's the decimal value. So if you want to print out the value using a decimal format, that's the decimal representation. You may wonder, how do we do the conversion? 25856. That's the decimal representation. It's a little bit complicated, but if you write this number out using a binary representation, then you can convert the number. But let's see how it works. So remember, we have 6500 hexadecimal number, right? And let's use the calculator. But this is all doable using by hand. You can do a hand conversion. So remember, the value is 6500. So let's clear this out. We put a hexadecimal here. So this is going to be 6500. What's the decimal value? See here? 25856. Right. And that's exactly the value being stored here. Right? Make sense? It's like magic. There's no magic behind this. And so at some point, I hope that using this simple program, it's a simple experiment. I hope that at some point, when you run a specific program, before you really see the output, based on this input, based on the ASCII table, based on this specific function, you can predict after buffer overflow attack, what's going to be really stored within the buffer. You can predict the value. I can do it now. I hope you can. All right. It is not so complicated. All right. So a little bit details behind the experiment setup. So the experiment requires a computer with a Linux system. If you know how to install a Linux operating system, you can do so on your own computer. It will not damage other people's property. So it will not violate any of the policies here at NSU. Okay, so be assured that I think a simple way, if you have a Windows machine, laptop, I did this on my laptop. I installed a subsystem, which is called Windows Subsystem for Linux. I will tell you exactly the instructions, how to install it. You can download it from the Microsoft App Store within the Windows operating system. It's stored within Linux Windows operating system. It's a special program, which basically will set up a virtual environment for you to run Linux commands. I'm going to show you a little bit details. Or if you don't feel comfortable, changing any of the settings in your computer, you can do this in the computer lab here. I have everything being set up for you, but I hope that you can do your own independent experiment, right? So you will do a little bit additional research. I think a good way to do a little bit, here we have 4 slots, so feel free to sign up any of this, but you need to sign up the day before the experiment. Okay, remember this. But you don't have to do this. You can do this in a standalone computer or from your home. Okay. So here we have some references. I think there are some good sources online that you can read. One good source is called Wikipedia. You know, actually the example was obtained from the item for Overflow in wikipedia.org, right? Including the example here, we have included here. Right? Very concrete technical details. They also show you different types of overflow attacks, right, based on different data structures. Very good explanation. So feel free to read it. Since I'm showing you the Wikipedia page here, I have a little bit extra words here. When you write a research paper, it is not recommended to cite a Wikipedia page. Don't ever cite a Wikipedia page as the main reference for your research paper or your project. Why is that? Because the content here is highly volatile. The content you see today might be different tomorrow because everybody has the right to override the content. Right? If you are a registered writer for Wikipedia, it gathers information from different users. So you can change the content next thing. You see, there's an edit button here, right? If you are a valid user, normally they will go through a checking process to see whether you submit meaningful content, but the content itself is highly volatile. This is not scientific research, right? So although in many cases, I have found the Wikipedia page give you excellent sources of references, and you can get into a topic very quickly, very solid technical content, but don't cite it. If you really like the content, it shows you different citations here, number 6, number 7. So feel free to cite any of the content attached at the end of the page. See, of course, they are not following APA format, right? But you can feel free to cite any of the content here, but not the page itself. All right, make sense? Make sense? Those are solid publications. Once published, you can no longer modify the content. It's the royalty is being normally transferred to the publisher, right? So you cannot, once they are being published, you cannot change the content. Normally, those references are coming from the good conferences and good journals. So feel free to cite any of this, but pay attention. Some of the material could be very dated, such as the ASCII format. ASCII format is a very old format, although we still use it today, but you don't have to put any reference there, okay? So these are very solid components. Even for Wikipedia page, if you want to construct a Wikipedia page, you need to do a lot of research, okay? And see, there's a very long reading list here, over, let me see, 47 references, only for the Overflow tag. If you use any of these materials, feel free to do so, but try to reference some of the newer publications. Overflow attack is an evolving world. There are some new attacks still fall into Overflow, but there are some smart ways to attack system. Okay. All right. Okay. Yeah, I highly recommend you, before your exploration on a technical topic, you go to their Wikipedia page. And for example, intrusion detection system, deep learning, different machine learning techniques, you can find a reference here. Very solid content, very good, especially for beginners. Okay. All right. So that's the Overflow attack. Let's show, it can be more complicated. Sometimes we need to pad a space using what we call the no-op sled. Basically, the basic idea is that in order add a large storage space so that it cause overflow to some adjacent parameters. The large space has to be filled with something, right, in order to reach the boundary for the other parameters. And those operators are called no op. We basically tell the computer, don't do anything until we crash your program, right? So that's called no op slang. This is an operator that is frequently used for different types of buffer attacks. But in our experiment, you don't have to do that. So here is the memory space. Here is the hexadecimal representation of the memory space. And here are the content. Right? Here are the content. Okay. And here, those instructions is to jump from one register to the other. This is highly specific to different architectures. Different architectures have different commands and different registers. Registers are basic units to store data or instructions inside the memory space. Okay, and which also controls the flow of the program. That's the assembly code. So if you really want to go deep into the technical details, you can buffer overflow attack. You got to be an expert in assembly language. Okay, this is a highly technical topic. To conduct a real, meaningful, non-trivial buffer overflow attack takes a lot of effort. Remember, we talked about the very first worm for the internet, the Morris worm. That is a buffer overflow attack. Robert Morris designed the program to explore some vulnerabilities behind the early ages of the Unix operating system. It takes over hundreds of computers. That's a big proportion of the internet at that time. He was being sentenced, sentenced to jail for a couple of months, and later he was released. And now he's a professor at MIT. He's a highly intelligent guy. Okay. All right. So you have to have a smart mind in order to start a brand new attack. Nobody did this before, but you can bypass all those security mechanisms. I hope that you can become an expert in the future. If some of you will work for the federal government, for FBI, National Security Agency, the CIA, some of you might be involved with some of those secret programs. The government has an inventory of different weapons, and cybersecurity is one of this. Okay. One of my students previously worked. He was a master's student. He worked on one special command for the U.S. military called the Space War. And after his graduation, he came back and talked to me. He's not allowed to reveal any of the details, any of the secret projects he's working on, right? So the attacks, the U.S. has a lot of tenets to design the attacks, right? He never revealed this to the public. Yes.
Was he in the military before going to school?
Cool.
The dude you're talking about?
For the student?
Yes.
No, he's a transfer student. But once we have a special scholarship program here. We do not issue the scholarship, but NSA will give you the scholarship. If you are competitive enough, we can submit your application on your behalf. And there are two types of scholarships. One is called the DoD, Department of Defense, Cybersecurity Scholarship. The other one is called the SFS, provided the funding source is National Security, it's the NSF, National Science Foundation. The basic idea is that if you are qualified, you basically submit different applications from all over the country. They put all the students into a pool and then select the top students. So it's highly competitive. But once you get a scholarship, you get full ride coverage on your tuition, and you get coverage on your books, and also you get a stipend. I think for undergraduate students, you probably get $1,500 a month as a stipend. But you have to sign a contract. Depending on the time you are being supported, you are committed to work for the federal government for the same amount of time, which means that if you are being supported for 2 years, you are committed. It's a contract. You cannot find your own employers. You have to work for the government, and the government will normally find a placement for you. They will give you a job, all right? but you are committed to work for the government for at least 2 years. But many people choose to stay on their job even after they finish their contract, right? Because this is highly technical challenging. You are working with the smartest professionals in the country, and you develop some secret weapons. Okay? Maybe you will start another stocks attack against another foreign government. Remember, in this internet age, every government is doing something similar. Not only the Iranian government, but also Israeli government. The U.S. government is doing the same thing. Right? You got to be able to attack other governments in case when it is necessary. Did that answer your question?
Yes.
Okay. And this is not easy. You have to be an expert in the area to be qualified. But at least, if you are in college, you maintain a very good GPA, you have a very good track record, jump into the e-hackers club, get some national awards, then you have a good chance to get that scholarship.
I was in the military, so I knew I would be competitive if I finished my degree and
Okay,
applied for a 3-letter organization.
yeah, all right. So you know some details, about this. Yeah, you probably come across some people, working under the scholarship. I think this is the way how the U.S. government want to attract the talents from different colleges, and we want to keep our arsenal of secret weapons. And the people is the most important factor, right? Okay. All right. Let me show you how set up the environment and run the command. By the way, here. Within the release document in Canvas, we have some setup steps that tells you some of the details here. The experiment was adapted from a course from University of Florida. This is a graduate level class. So if you are qualified of doing this, you're competing with some of the UF graduates, right, at the graduate level. Okay, so you should be proud of it. So here there are some brief discussions here, and also Overflow attacks. This is the page that shows you how to set up a Linux environment in Windows. All right. The default version for there are different versions for Linux, and the default version for the Windows Linux subsystem is called Ubuntu. All right. Ubuntu is a very popular Linux operating variant that are commonly used by the hacking clubs, including here. At NSU, we have a e-hackers club. They are trying to study some details behind Ubuntu and other maybe Kali Linux, right? So these are the instructions, and here is the web page that shows you how to install Linux on a Windows machine. All right, it's called Windows submachine for Linux. Okay, detailed instructions. I already installed this subsystem on my machine, so I'm gonna run it out. So this is called WSL. It's a virtual machine being hosted on top of the existing Windows box, right? So you can see the prompts are different from the Windows box, and you should be better familiar with the basic commands in Linux system. So like cd here. CD is changing directory. PWD shows the current directory. So the way you can connect the Linux operating system to your own local machine is through a series of commands. We have a special command called mount, MNT. Actually, your hard drive has already been mounted into the Windows, into this Linux system. So the default directory is here. So cd/ means we go to the root directory. There are different subdirectories here. One specific directory is called MNT, right? So this MNT is called mount. If you have any external devices like a hard drive, flash drive, or input/output device, they can all be mounted into the system so that you can access them later. So in order to access the content on my hard drive, we go into mount. You can see different letters. The letter C is actually the drive's name. This is my hard drive. So C is my hard drive. And then I can have access to all the files on my hard drive. Here, the purpose here is that I have some programs being installed here, and I want to execute them. So in order to access those programs, I have to first access my hard drive. So CDC. So these are all the files being stored, and I have set up a subdirectory called buffer overflow. So let me go into it. Look at the content. Right. So here you have 3 parts of the experiment, and the difficulty level will increase. So I'm gonna do part one. Okay, and let's see how it works. So this is how I go into the part 1. Right. So this is the part 1 directory. Different programs. There's a C program. If you want to know, this is open source, so you know all the content here. In order to show the content here, I can go back to the prompt on my computer. It's C drive. So this is part 1. I already, decompressed all the files here, so you can access all the content. If you want to show the C program, use editor. I use Notepad++. So that's the source code, and you can read it and predict the output. And in order to run the program, you have to go back to the Linux subsystem. Okay. So there's a special command. Let me show you. I want to mention a little bit.
Is it a G++? Or you can also you can use that to compile the program.
The C++?
G++.
No, I use GCC.
It's the same. It's just.
It's the same thing.
Yeah.
Yeah, it's a different compiler. GCC by default is a built-in compiler for most of the Linux distributions, right? So let me show you the command here. This is how we compile the program. You can see that's a -W F no stack protector here. It's a default. In order to execute the command and disable all the security features, you have to add this configuration. Because I have full control over my computer, then I can add this parameter to disable the boundary check, right? Yeah, you have to use this feature, otherwise it will not cause buffer overflow, right? So it has some other parameters. You can just copy and paste, right? So here is the input file. That's the .c file. And here is the output file, right? We use the same name. Right? So this is how we compile the program and into machine code of it. Copy and then paste it. All right. So execute the command. Oh, you have one additional file here. So that's the new file that has been generated. Okay. So and now you are ready to execute the program. So that's the outcome, right? 1979. So you can I hope that before and after execution, you can somehow predict the value. You have reference to the source code. You try to understand the program and predict what happens after the buffer overflow attack. The thought process is very similar to the case study we just introduced, so it's not super challenging. But part 3 involves the memory location of specific program. That's a little bit advanced. You will need to do some extra research in order to understand the program. Okay, so only part 3 is a little bit challenging. Part 1, part 2 is very straightforward. Okay, all right. I think that's pretty much I want to show you today. Hopefully you can enjoy take this chance and explore some fun stuff. And at least you know there's a hands-on component for this class. I really hope that you can enjoy it. Right, but again, it's an option. You can choose other options. All right? Thank you very much. I will see you, on Thursday. If you want to sign up, try to make an appointment with me as soon as possible.
Thank you, sir. Have a good one.
Yeah, you too.
So this is for the end of the summer report, right? With the project at the end of it.
Yeah.
And so, like, I know that we can't do it at home, but those times are for doing the lab in person, right?
Yeah,
So,
we can do it.
okay, I was confused at that, so like the computers,
Yeah, even if you choose this option, you can do this in your home.
okay, and the computers, they're gonna have Linux on them, right? The ones that are doing, okay.
Same thing, it's a Windows machine, but I install Linux subsystem.
Okay, all right, thanks so much for
All
this.
right, think about it.
Have a great one.
You too.
Thank you.
Thank you. Please sign your name here before you leave, okay?
So, on my project proposal, I didn't include like the protocols that I wanted to talk about, like in my research list. But when I do like my actual project, I will, because I know you said like me putting that in there is not really
You
research.
revise the document and send me an updated version.
Probably, it's locked, so I just wanted to let you.
Yeah, you can send me an email,
Oh, okay.
all right? Yeah, you can say that, the only difference is that I add additional references,
Oh, okay.
okay?
Really quick, I think I just went back
Sure.
and, I know you said focus on one of them. The only reason I figured that one out. Okay, so I'll remove the behavior one and focus on deception, just machine learning.
Right, that
And then-
topic is challenging enough.
It is, yeah. And then, I will remove that. And then you said avoid long and broad. But my plan is not to go broad on it,
Sure.
just to give like.
Yeah, if it's just a short
Yeah.
paragraph.
That's why I just put that in here. I didn't really mention the link.
Okay.
So I don't know if you deducted points for that one or not. And
Yeah,
then.
it's just that
did
I
have
want you
a
to
lot
have
of
a
issues.
narrative, that's the main comment.
I mean,
The
if I
first one-
just do the machine learning one, it should be fine. Then you said additional references, but I was gonna add them when I actually
Sure.
start writing.
Yeah,
like,
yeah,
because
Yeah,
it's
show me
already
some
hard.
key references, yeah.
I
Maybe two,
did.
three of them.
I did show them,
Yeah.
after my benefit.
I need you to, not only
To
the
just put
reference,
them in like the body.
exactly,
Okay.
you tell me exactly.
Okay,
Machine
I was
learning is a
just-
huge
Yeah,
family.
I was just confused on what you meant with the feedback. That's why I was like,
Yeah.
I might as well just ask them in person.
Yeah, once you go into, specific, machine learning models,
Okay, I
Probably
did,
you
I
will-
did say that.
you
I
will
did
need
mention
to
that.
dig out more papers.
Yeah, I did, okay, can I not make this work? No, I don't want to do that, please. I'll just have it. I have it somewhere over here. Oh, also the other thing was, could you unlock assignment 3 for me? I submitted the wrong.
No, you just send me an email.
Oh, I just sent you an email about it, okay. Yeah, sorry, I thought I submitted the right one, but I submitted the wrong export, so my article is just not there.
Okay.
So on this one, because this was the part where I was gonna just do a small screen. Put that in appendix and reference it over here, and explain that, hey, that's how high quality
Yeah.
works.
I want you to tell me
Yeah.
which machine learning technique
I-
can serve the purpose
Oh,
for your
okay, did I
deception.
not mention that? I thought I did.
It's very rough, very rough,
Okay.
yeah, very rough description.
Okay,
It
yeah.
did not
Okay, I
mention
didn't know
specific
what
machine learning.
Okay, I can change that, okay.
Yeah, Kotlin is a huge, very broad family,
So that's the one thing I need to fix then.
okay?
Okay, I just.
Yeah, that's
I was-
pretty
I
much,
just
I want,
asked, yeah.
I want you to make the topic feasible.
Okay, I
We
was
don't
just
have a lot of
confused
time.
on what you
Yeah.
meant with that
The
one.
more concrete the topic is, it means that you have some solid ideas how to do this.
Yeah, I was just confused on what you meant with the feedback. That's why I was like, I should probably ask before I resubmit it on
Sure.
Sunday,
Yeah.
but I don't think I can resubmit anymore.
You can send me an email.
Okay.
Yeah, this is
Yeah, I'll get it done.
not way too late, so
Okay, yeah,
if you can do it quickly, I can.
I
still-
can get it done by
Yeah,
like
yeah, yeah,
tomorrow-ish, because I'm trying to get everything done by tomorrow, because I'm flying out Thursday.
okay.
So yeah, I'm gonna attend the class next
Coming
week.
back, in 2 weeks.
In a week, so
Okay.
I'm out for next week and that's it.
All right.
So yeah, I'll attend the next week class online, because I'll be at the conference like I told you.
Sure.
So, yeah.
All right, have a good trip.
And then NCL, oh, yeah, I'll show you that one as well. The team game happened. We can't see specific scores for who scored what, and we can't see the other team.
If I can see it, I can
You
give
should
you
be
a
able to,
screenshot.
you should be able to, but,
Yeah, yeah.
this was our team at least, me, Scott, and one of my friends.
Maybe let me stop the recording, and maybe I can do it.